Welcome,
Super.
everybody. Thanks for joining us today. So, Tim, as people are joining now,
we'll see some familiar names in the attendees list, which is always good to see. Hopefully, can't see their friendly faces, thankfully, which is why I like these things.
I wonder how many of them are AI bots. Hopefully, none. So, in the interest of time, because we did promise this would not be a long, drawn-out webinar, we promised something snappy and short and get to the point, didn't we, Tim?
Yeah, definitely.
But the convention of the traditional hour-long webinar, try and get this done in half an hour.
Yeah, and I've timed myself this morning. I think I'm about 25 minutes. I'll try and be brief.
Perfect. Okay. So, to start with, we'd like to get people's answer to the following question, which is kind of the principle of what we're going to talk about here today. And the question is, as it's popped up, do you trust your metering data? Essentially, that's sort of a core concept of what we're talking about here today in terms of Tim's presentation, looking at any strategy, whether it be ESG, net zero, or just because you want to save some money and save some energy. It starts with having good data, and it starts with trusting that data. So if people can give us their answers, not on a postcard, but definitely by clicking the poll, we'll get a sense of the temperature of what's going on. And while people are doing that, Tim, could I ask you to share your screen, please?
I can. Here we go. Hopefully everyone can see what I am doing.
There we go. We've got you.
Shall I make a start? I shall kick
off.
So,
for information, we've got a sort of a split, sort of a 33% of people, yes, they do trust, 33% no, and 33% maybe. So you're in the right place if you are in the no or maybe camp. So, Tim, I'll sit in the background for anyone who wants to drop anything in the Q&A. I'll be there to try and pick that up and flag it with Tim. But off you go, Tim.
Thank you. Thank you, everyone, for joining. I recognise some names in the thing, so if I've met you or spoken to you before, thank you. If not, pleased to meet you. So I'm Tim. The first thing I'd like to say is that I am passionate about metering and doing it properly. And the reason that we sort of came up with this slightly strange name, Ditch the Clipboard, why net zero starts with data you can trust, is because in the time that I've been with Aphex, I am still seeing organisations managing their metering data by walking around sites and recording the data with a clipboard. And I can't believe that in nearly 2026 we are still doing that. So let's take 20 minutes to explore why I think meters are the foundation of your sustainability goals and how you can use them to validate the actions that you need to take. So the uncomfortable truth about energy data. As we know, today energy is a major issue for us all. It's rocketed in cost recently due to all sorts of events around the world. And we're more aware than ever that it is a finite resource that we must be careful with. Organisations are having to make decisions based on both compliance with targets for sustainability, but also controlling costs that affect their bottom line, because using less energy makes you more profitable. Peter Drucker, of course, said you can only manage what you can measure. So when you've set yourself your goals or you want to make more profit, how are you going to know if you've got there if you've got no accurate data to go by? And most metering systems are like sausage machines. If you put rubbish in, you will get rubbish out, unfortunately. And as I've said, there are countless sites that I visit, we've had it in the poll, that they do not trust their metering setup. And today we have a raft of technology, and it's hard to believe that people are still sending teams around with clipboards to read meters. So what we'll cover today, six sections. We'll look at some trust questions first, seeing whether you can trust your metering setup. We'll look at what different levels of data looks like. We'll look at how to install meters and get insights out of them. We'll look at a case study of how we've done this to save money for an organisation. We'll speak some finance because somebody at some point is going to have to pay for this. And then at the end, excuse me, we'll give yourself a quick self-assessment, some questions to take away to look at your projects, what you're trying to do, and see if it's working. So strategy without measurement is expensive guesswork. No, none of us, I would imagine, want to waste energy. If you're like me, I have a son back from university now. So all the lights are on, the freezer door's left open, the kettle's on constantly. So we all know we don't want to waste energy. But how are you going to know that your strategy is going to work? You know, like you're going into dad mode. Are you turning the heating down? Are you replacing the lighting in your office for LED bulbs? How will you know you've made a difference if you've no evidence to back it up? So the 4 trust questions that we're going to ask ourselves. Oh, I think I've jumped. Apologies. Right. Question 1. The first question you need to ask yourself, are your meters accurate? So I think the first question is, are they fitted to the right loads? And if you've got meters already, do you know what it's doing? Have you got a meter labeled LL? Is that doing lighting load or is that the landlord meter? Are you sure? Has anybody at any point switched that supply off to see what power's down when you do that? Have you validated your meters? Does the electricity usage your electricity meter shows, is it the same as what you'd expect? Has anyone compared it with a clamp meter or a calibrated meter side by side? I should say I'll probably talk a lot about electricity meters during today. That's what we do, but the principles remain the same whether you're gas or water or heat. How old are your meters? A meter's lifetime is estimated to be between 10 and 20 years old, but I've seen older. I've been to a site down in the south of the UK where the meter looks like it was fitted around the 60s. The dial meter's still spinning around and they're still billing the tenant from it. If I was that tenant, I'd be asking questions as to, is that meter really accurate? Are my bills correct? And are you using pulse-based technology? And we know that sometimes that's necessary for gas and water. But if you're collecting pulses and you're missing them, they're gone forever. They can't be captured. So I think today we should be specifying register-based technologies, Modbus and MBus. If for any reason the communications drop out, the register will pick up and that usage will be captured further down the line. So, question 2, are you monitoring the right loads? And not talking about is it the right circuit like we did a minute ago. I'll talk about a little case study here that we worked with a motorcycle manufacturer. They had a problem, and that was the problem that they came out of their electricity contract. And so their fixed price ended and their electricity bill shot up by 3 times. So finance then think this is an issue. And so because it's money, finance then want an action. So they go to the maintenance department and they say, where's all this electricity being used? You need to get on top of it. And the maintenance team thought they knew what they wanted to do. They thought that the energy would be used by compressors on site. But they had no visibility. What they had was a utility bill that came a month after the event, and probably by the time it's worked its way through finance and got back to them, it's 6 weeks after the event. So we worked with them, and in a nutshell, what we did was we installed metering on their LV panels so that they could rank the areas of the site into their usage. And the area which they believed was the highest usage panel, we installed meters on every sub-circuit that we felt that we could control. And they were right. It was the highest usage. But what they were surprised about was that their thoughts on the compressors were correct. But what they didn't realize was that the production machinery, which they left on overnight between shifts, was using huge amounts of power. So we installed the metering, we ran a baseline period for them with our system. And what they did was, after getting some good baseline data, they made adjustments to the compressors. They powered the machinery down when they weren't using it, and they instantly saw a 20% reduction in energy use. Great result. So question 3, are you capturing enough data? what granularity do you need? And I think the image on the page is a brilliant example. It's exactly the same image, but using different amounts of dot, you can see more of the picture. So if you're doing tenant billing, hourly or half hourly might be totally sufficient for what you're looking for, but it won't give you much insight as to what's happening. If you're trying to spot patterns or rogue usage, then maybe drop down to 15-minute data and you'll see spikes of bits of plant kicking in overnight. You'll be able to identify the times that things are operating at greater detail. And if you're looking for really quick faults, transients, anything like that, bits of kit that are failing, maybe only for a few seconds or minutes, you can go minute by minute, or even with some of the Janitza meters down to the millisecond. The greater the granularity, the greater accuracy, as the image shows. But also bear in mind that there's more data to process. So you've got to be able to handle that amount of data coming at you. So you need to define at the start what you're trying to achieve from the system. And possibly, again, importantly, are there gaps in your data? Are there periods where your data doesn't flow, doesn't work for a week because you've got comms failures? Question 4. Are you measuring what you can manage? Back to Peter Drucker. Part L of the building regulation states that we should install meters to cover 90% of a building's load. But I think the question, why are we metering circuits we have no control over? I'm sure we've all seen countless meters fitted to fire alarms, firefighting lifts. No one is going to turn these circuits off to save energy. Do you have meters on each key piece of equipment? Or is it, lumped together as the mechanical board? How are you going to know what those pieces of equipment are drawing individually? Or are you just seeing a total usage for all the plant in the building? Better data gives us better insight to make decisions on how to save energy, but that's only useful if you can control the load that you're measuring. If this was a new building, the metering strategy would usually be completed at the design stage. An architect would come up with it, but I think it's still important that even if it's been put in place, that should be reviewed. Let's make sure it's robust enough. And if we're looking at existing buildings, lots of them don't have much more than just a main utility meter. Undertake a full site audit, see what metering's there, see what looks good, what needs to be improved, see what plant's there, what heavy usage, what you can meter, and then we can monitor it and we can make, we can save energy based on the information we get. So 3 levels of data. What does good look like? So if we looked at it as a ladder, lots of buildings, all they have is the main meter. It will tell you what your usage is, normally once a month, but you'll have no idea where the energy is being used. You might have a strategy, a concept of what you need to do, but you'll have no idea how to go about it, how you'll know that you're making changes. The next level, which is better, is sub-metered zones. So whether that's metered by floors or buildings or tenants, lighting and power. And with more granularity comes more insight. You might spot that one floor of your office leaves everything switched on overnight. Then you can go and speak to them and say, look, we're trying to make some changes here. Can you help? Can you work with us? And then finally, circuit level monitoring. More and more common, more and more solutions that are helping us. Pieces of equipment that can be used to monitor every outgoing way of a distribution board. And here you will spot the piece of equipment that is causing the issue straight away. You'll be able to see it. You'll be able to see if something's gone into fault, if something's not working, and you'll have the data to hand. So the takeaway from this, as it says, the level you need depends on your strategy, but you can't start with basic data. If you're just looking at the utility meter, you're not going to get sophisticated results.
Tim, just before you jump into that, let's just launch a quick poll with those trust questions in there and just get a sense of, from what you said, just some initial feedback about whether people believe the meters are accurate, whether they're monitoring the right loads, are they capturing enough data, or are they measuring what they can manage? So if people wouldn't mind just responding to the poll there quickly and just get a bit of a sense of that before we move on, Tim.
Thank you, Neil.
And if anyone has any questions anytime, please just drop them in the chat. Okay, so got some answers coming in. So are your meters accurate? Sort of 50-50 between yes and maybe. Are we monitoring the right loads? No one said yes. Mostly no's and a maybe. Is enough data being captured? A resounding no on that one. Now they're measuring what they think they can manage. That's sort of 50-50. So some interesting points there. While we're here.
Super.
Okay, Tim, crack on.
I'll carry on. So
Yep.
part three, installation. Let's see how we can do this right. So we've covered in the last couple of sections how we're going to design our metering strategy to ensure we're monitoring the right loads with the right granularity. Now what we're going to do is we're going to use that. We need to, work with it. So first of all, we need to select the right meters for the job. If we're going to use them for billing purposes, we must make sure they're MID compliant. My opinion is most meters these days are. There isn't a huge difference in price between non-MID and MID. So as our rule of thumb is we always try and provide an MID meter. What's the draw of the load we're connecting to? Again, rule of thumb, if it's under 63 amps, try and use a direct connect meter. CTs aren't as accurate at lower current, but we're aware that it's not always easy. Sometimes loads can't be disconnected to put through it, so sometimes it's necessary to get some smaller CTs, and they are available. And then consider what communication options you need. We're going to need to get the data out of this meter. Register-based meters should always be specified, but whilst we've historically had Modbus and MBus and run lots of serial cables around buildings, now we need to think if wireless communications can be used. LoRaWAN is a huge game changer, and whilst they may have great hardware costs, there's costs to be saved in terms of installation, less cabling, quicker deployment. Once we've chosen our meters, we're going to consider where the data from the meters is going to be stored and used. So a small remote office with 3 meters, electricity, gas, water, that doesn't require its own on-premise solution. Data could be sent off-site via a router to a cloud-based system. A data center, on the other hand, with 2,000 meters across 6 halls, that would definitely require its own on-premise. So, totally different. The architecture needs to be thought of, based on the building. And once you've got that metering data, you need to ensure that it's being used and being used properly. Too often I hear that the meter data is, quote, in the BMS, which, no offense, I'm not sure if there are any BMS people here. The BMS people love meters because it's adding points to their point list, which means more money for them. But invariably what that means is there's a page somewhere on the graphics with some meter readings that were shown during commissioning, and that data's never being passed on anywhere else. No one's doing anything with it. So sort of the image there shows obviously we like to get the data off-site cheaply and effectively. You can find a lot of the routers these days, you can put serial comms straight into, fire it into our cloud, and then we can use that data, whether that's in an analytics package, graphing and charting and reporting, whether we're billing with it, or whether we're doing some power quality analysis for something like Griffiths. Installation. All of the strategy and equipment selection will be wasted if the meters are not installed and commissioned correctly. And I think one of the big problems is that the metering is normally part of the electrical and mechanical package on site, and this is a headache to them. It's often part of a panel that they just assume works, or something that they don't want to do. So let's talk about how we feel you can make sure that you're getting the metering installation right. Excuse me. So first of all, before you start, ensure that you've got the right meter for the application. When you're standing in front of it, does it look right? Is this the meter I need? If it's not, stop and let's start again. And then, as we spoke, let's perform a physical check. Certainly if we're retrofitting, by powering off the circuit, that the load you think you're monitoring is the correct one. If you think you're going to monitor the lights and you switch them off and the lights go off, we started off in a good place. If the sockets go off, we need to have a look. And again, we're all aware that distribution boards are often labelled incorrectly or not labelled at all. Once we come to install the meter, let's ensure the connections are installed with the correct polarity, both for direct connect meters and for CT installations, making sure that the CT is installed in the right direction with the arrow following the normal flow of current. Both, if you connect them wrong, will register the current flowing in the wrong direction, which will give you the wrong power. We need to make sure that the CT cabling is adequately sized. And again, the polarity of the secondary connections is correct to the meter. So if they're reversed, again, it will show that the meter is working in reverse. Undersized secondary cabling over a long distance will give you erroneous readings. The meter sees it as a resistive load. It needs to be big enough to cope. Electricians, unfortunately, fall down when they think it's only 5 amps, and a tiny bit of 1 mil cable will do. We've installed this meter and we followed all these principles. So what are we going to do next? We need to ensure that the meter is set up correctly, because we can't just leave it at that. I think it's going to work. We need to set it up and commission it. So if it's a meter with a current transformer, we need to set the CT and, if necessary, the voltage transformation ratios. We need to make sure they're programmed and locked into the meter. And we need to make sure that the comms settings, Modbus addresses, taking LoRaWAN keys, that's all recorded, set, and written down. And then I think the most important bit, and lots of sites you look at, the meters are installed and commissioned, often with no load on, because at that point, the centre's not, or the place is not operational. So we need to put a load on the meter, and we need to test that meter with a calibrated reference meter and compare the two. Do they look the same? And if they do, excellent, then we're going in the right direction. After that, ensure that the label at the meter point is correct and it matches the meter schedule which you've pre-agreed with your client. Then, obviously, if the meter's MID, we can seal it up, make sure it can't be tampered with. And I think most importantly, let's record all these results, write them down, put them in the building's manual, make sure they're available so that someone can look at them in the future. So part 4, we'll look at a case study. Tenant billing's huge area for metering. Landlords, building owners want to recover their costs. They want to get their money back. And it's critical when recharging for this that the metering is accurate and that the right tenant is being charged for the right meters. I have visited sites where there were 1,400 meters being manually read each month. That took the FM team on site 3 full days. Every month they are walking around with a clipboard writing the numbers down, just because they don't trust the system that's in place. Fully automated systems such as our Aphex billing, they can remove this task. We can make sure that the meters are accurate, they're working in, and that you also don't have the time-consuming process of taking those readings from the clipboard, entering them into the system, manually creating invoices. All of these steps can lead to errors being added in. Tenants aren't, billed correctly. They don't trust the system. So let's talk some money. How are we gonna get the budget to do this work? So these systems need investment, and you're going to need to go and see the money people, whether it's the CFO or the finance director. Someone's going to have to sign your project off, because there's usually somebody that's been given the sustainability hat in an organization. And when they start to see the costs involved in putting all this metering across multiple sites, they start to think, oh, no, the finance people think, it's difficult because, we're ever going to get a payback. So let's look at the motorcycle manufacturer. They identified 20% savings overnight. They saved £20,000 per month. Their system paid for itself in less than a month. We should have charged them. The multi-tenant customer who was able to remove the manual meter reads and automate the billing process has saved 40 hours of man time per month, with people not having to do those manual repetitive tasks. And then we look at revenue opportunities like demand side response. We've worked with companies with solution them to either able to meet the requirements set out in their agreements with the DNO when they're generating. There are periods when the DNO don't want loads to be put onto the grid, or being able to manage their load so that they can sell it back at a time when they get a better price when demand is required. We're coming towards the end. You'll be thankful to know we're near the end of the half an hour, and I bet everyone's hungry if they're not already eating their lunch. So part 6, let's rattle through your 10-point self-check. So we've talked about what's good and what good looks like. Well, let's give yourself 10 simple self-check items that you can do. So starting with your data trust. Do you trust your data? Ask yourself these questions. When were your meters last verified? Was it on the day they were installed when there was no load on it? Do you sometimes look at the data and think there's no way that floor can use so little power compared to the rest? What's going on? Do you have data gaps? If you're looking at you might have an energy management system, but every few days, the data drops off. There's no data for weeks on end. Check the last 3 months. Are there issues? People have already said in the poll, what's your data collection frequency? Would you like it increased? Would you like to see more granularity so that you can spot faults, see trends, see when things are happening out of hours? And I think the pulse or register-based meters is really sort of the question is, how old are your meters? Really, if they're over 15 years old, should you not be thinking about replacing them at this point? Coverage. What percentage consumption can you see at sub-meter level? And based on that, can you identify your top 5 energy consumers in your organization? And are you metering what you can control? The system capability. Can you see the data in real time? The game changer for the motorcycle people was that they could make changes, and within 15 minutes they could see that it had made an effect. It taken effect. They didn't need to wait a month for the bill to come through to see the changes were working. Is it integrated with your management systems? And can tenants and stakeholders access their data? I think that's crucial, because I don't think there's anyone in the organization who would want to waste energy, but showing them that the changes they make a difference is going to really get them to buy into it. So next steps, run the trust audit. Okay, so look through those 10 questions. We can share them out. Watch our socials, our emails. We will put those, give it to you. Then identify your biggest blind spots. What do you need to do? What do you need to change to make it better? And then once you've got that, do some figures, build a business case, go to your finance people. Let's get the budgets in place, and then we can work with you to help you. We're nearly there. I think takeaway for me, you can have the most sophisticated energy strategy in the world, but if you're not measuring it, or you don't trust the data that you're getting, you are still just guessing. And that's it. Thank you. Like I say, I'm Tim. I've been managing director of Aphex for nearly 6 years now. Aphex has been trading under a couple of names since 1992. We are experts in electrical submetering and integrating to any other meters. We have solutions for energy management systems, charting and reporting, getting data back to you. We're experts at fitting meters. We have a billing platform where we have a fully automated multi-tenant billing. We are set up as Janitza partner, so we can help you with power quality for commissioning Janitza and GridVis systems. And if you need anything else or have any questions, please fire away. I shall stop sharing.
Thanks, Tim. Actually, before you do, don't do that.
Okay.
Just flick forward one.
I think that's it, Neil. That's the end.
Oh, there you go.
Right. Oh, look at this. It's live.
Live and direct. So, a little insight on the polls. So half people aren't sure meters are even accurate. 0 are confident that things have been monitored correctly, and 3/4 don't think they're capturing enough data or aren't sure. So
I think the
looking at that, what does it tell you? And what are your thoughts on that?
I think, this is the first time we've run this webinar. We've done other webinars on tenant billing. the question of meter, do you trust your meters comes up time and time again. And they're the foundation. They're what you're going to build these systems on. So if you can't trust it, you're blindfolded, aren't you? You're not gonna. Let's get the basics right. And then we can, fire it into all the fancy charts and reporting.
Yeah, if you're making sort of big decisions and you're a few degrees out, just the old analogy of a plane flying and being a couple of degrees out ends up miles off course. If you're taking decisions based on the wrong data, time passes, and before you know it, you've made some fundamentally wrong decisions. So everyone wants the quick results, right? Everyone wants to keep moving, but stepping back and just going, well, before we even start, do we have a problem at all? And are we looking in the right place rather than spending all the time, effort, and money, making bad decisions just to find out that, it was based on poor data.
Yeah. You wouldn't do it in any other part of the organization. Your finance department don't guess how much money's in the bank.
Hopefully. Do you think it's a function of like people just, okay, well, it's my meter, or they just, they don't know any different and they just sort of believe it because the meters are in there,
I
or
think it's probably a lack of knowledge. I mean, I hear all sorts of, people will say, I don't trust the data from this meter. I think it's broken. They say, you look and you think, yeah, I think it looks broken too. Let's go and change it. And then you'll hear things like, we're not sure about this new meter. It gives a totally different reading to the old one. Well, yeah, the old one was broken. That's why we changed it. This one's working. It's accurate. We've tested it.
yeah,
You've got to
yeah.
it's not, I think we have to demystify that metering is some kind of black art that, it's
And going
really,
back to that, the slide you had around the resolution of data,
yeah.
I think was quite important because we work with other companies, right, where we're asking for half hourly
Mm.
data, which isn't
Yeah.
too extreme.
No.
And the rationale there is that if you're not going to enough granularity, you're just not going to see that variation in time about something that's doing something at a particular time of day. I recall a long time ago, a particular company just couldn't figure out what was going on, and they were making bricks, I think, and it was the ovens were coming on at the wrong time and causing this huge spike, which you wouldn't
Yeah.
see if you didn't have at least some granularity of data, not necessarily minute by minute, but some of the basics. So I think that resolution and frequency is important as well.
So many other, financial decisions that you can use as well. If we worked with a company doing printing. They got two printing presses. How do they know which one's most efficient? Once you're metering the energy usage of each machine, you can see, actually, not only can you see how many, boxes or whatever are being, produced every minute, you can actually see what's the cost of that. Might actually
Yeah.
be more cost effective if you're not, if you have, if you're time rich to use a machine which, makes less per hour, but actually makes them, more cost effectively.
And there's another kind of myth, I think, that just because something's on standby, it doesn't mean to say it's using less
Absolutely.
energy. I heard the other day from someone in the hospitality sector that these particular ovens that they use, the amount of energy they use on standby is frightening, and they could turn them off, particularly overnight. But people just assume it's on standby, it's not using any
Yeah.
energy. When let's just say it only takes half an hour to warm up. That's infinitely better than just leaving it on all night just because you think it's on standby, but you wouldn't know that that's a problem, particularly in multi-site environments where little problems add up across thousands of sites.
Lots of equipment as well. I'm aware being put on standby can create huge power factor issues. So again, sort of, reactive
Yeah, I think
power
there
and
was
wasting energy that way.
there's one pub chain I know we've worked with, and just looking at sort of six fridges in pubs and
Mm.
looking at the wastage of keeping them on all the time versus turning them off at night and
Mm.
bringing them back on in the morning was about across 100 sites was about £46,000. So these numbers add up at scale, and but you can't make any decisions on where to focus your efforts if you haven't got the right level of understanding of what's using the energy. So
absolutely, you're into the Dave Brailsford and the minute goals, aren't you? And
but I think it's just me and you just chatting whack now, Tim.
okay.
So
Has everyone else got bored and gone?
No, not everyone. Not everyone.
Are there any questions?
Yeah. Any questions before we sign off and bid everyone a Merry Christmas and a Happy New Year?
Yeah.
I think so. All right.
Thank you. Well, we must have done a good job
Tim.
if there are no questions. Thank you for hosting, Neil. Thank you, everyone, for attending. And we will be in touch. Don't worry.
Thanks. Take care. Bye.
Thanks.